take a look at this. Identify the parent function. What is the parent function for the first one? What is this parent function for a linear equation, for a linear function? Y equals x. Okay, what about this one for a quadratic? What is the parent function?
X squared.
Y equals x squared. Okay. All right, we did a little bit of domain and range yesterday. Let's review. Domains are those x values of our relations. Okay, so if I'm looking at a table or a mapping diagram, it's going to be on the left. The range values are going to be on the right because those are our y values. Okay. The mapping diagram, it's going to be on the right. Okay. How do you find the domain from a graph? With points, you must find the x value of every point. So here's what we're going to do. I'm going to take my cursor, okay, and I'm going to drag the domain over here. What is the domain? X value. So I've got -4. What's next?
-3.
Next?
-1. 0. 2.
And 2. Okay? That wasn't so hard. Let's do the range. How do I do the range?
Y.
Those are all of our y values. So I've got -4. What's next?
-2. 2.
2 again. Okay. 4. Okay. Don't forget if it's range, just because 2 appears twice, you're going to indicate that it's 2 twice. Okay. If it's 1, you need to list it in a set. How do you find the domain from a graph when there's a curve? So, remember that you have, hold on, let me grab a pen. Points that are continuous, okay? So, my domain goes from here all the way to here. So how do I figure out where my domain begins?
At the top.
So it looks like it's at 5, right?
Yeah.
Wait, isn't it like slightly curved?
Yeah.
Yeah.
Okay. What about here?
1.
1. So I would write it as -5 that's less than or equal to x, which is less than or equal to 1. Okay? And we'll do that a little bit here. Let's do range. Where does my range start?
-4.
At -4. Okay? So -4 is less than or equal to y. And then if I keep going, does it continue?
Yes.
It continues until
5.
infinity. Okay? Alright, I'm not really good at drawing the infinity symbol. But the points are going to continue on forever. It doesn't stop, okay, when we're going this way. So remember, when you get on the test, your domain is your x values. So if you need to write this on your notes before you take the test, you can write on it on your scrap paper that you get. And the range is your y values. So you can write it like this just to help you remember, okay? Domain is x, y is range.
Hold on.
Ooh, good. Go back.
Those
Yes, please.
Alright.
Okay? Okay.
Was it loading?
So I'm going to show you a little bit about continuous and discrete. So our first identification is if a line passes through my points, it is continuous. If a line connects my points, the graph is continuous. If a line does not pass through my points, it is discrete. That means if I just have dots on my graph, it's only discrete. My domain and range is continuous if it is written in inequality notation. Okay? We just did that. With our parabola, we wrote it in inequality notation. It means the graph was continuous. My domain and range is discrete if the coordinates are listed in a set. We just did that. We listed domain in a set and range in a set for our x and y values. Okay? Okay, put the phone away. All right, determine if each representation is continuous or discrete. Is this one continuous or discrete?
Continuous.
Continuous, because the line continues. Is this continuous or discrete? Discrete, because it's listed points in a set. Okay?
Can you go back to that last page?
The line passes through what? It's continuous?
The line
The
passes
dots.
through all the points. It's continuous.
What can you say, please? The points of a continuous graph.
They're not. They're not going to say that this is a continuous graph as they list the points. The domain would be listed in inequality notation. Okay? What about this one? Is this continuous or discrete? Continuous. What about this one?
Discrete.
Discrete. Okay, what about this one?
Negative.
Continuous. What about this one?
Discrete.
Discrete. Notice how I just have dots. I do not have a line that is indicating that it's continuous from one point to the next. It stops here, picks up here, stops there, picks up here. Okay? All right. Take a look at let's talk a little bit about distributive property. Now, you guys have done a lot of this distribution between variables, simplifying expressions, factoring polynomials. Factoring a polynomial is undoing the distributive property. Okay? So if I distribute one number to the rest, I have x times 8, x times 3, which gives me 8x plus 3x. 2 times 4 plus 2 times t, which gives me 8 plus 2t. 8 times 3m plus 8 times 6, 24m plus 48. Commutative property. I can change the order, but it only works for addition and multiplication. Commutative does not work for division or subtraction. Commutative basically means if I have 7 plus 6, it also equals 6 plus 7. But if I subtract 7 minus 6, it is not going to equal 6 minus 7. Okay? 7 minus 6 is 1, 6 minus 7 is negative 1. Okay? It does not work. Same thing for multiplication. 3 times 5 is the same thing as 5 times 3. It does not matter in what order I'm multiplying. It's going to yield the same answer. Okay? Associative property. It's the same order, but the parentheses go in a different spot. Basically, they just shifted the parentheses from 4 plus 6 to 6 plus 8. It does not matter in what order I am adding. Okay? It's going to yield the same answer. Same thing here. They just shifted the parentheses to 6 plus 10. Now, when you guys are doing the associative, commutative, and distributive property, you're basically combining like terms, you're multiplying coefficients, you're just simplifying algebraic expressions, okay? And you guys have done this before, you probably don't remember the actual definitive terminology for it, okay? You guys ready for me to move on? Because we're going to do some practice. Yes.
So here, what if we would move them so it would be easier to, like, put it into all.
This is a different way of grouping numbers. So you might see numbers grouped a certain way.
Yeah, like if it's really weird, so you can easily put it into the equation.
Yeah. Okay. All right, let's do some practice. What's 2 times 2 plus x? 4 plus 2x. Okay. What's y times a minus 3?
1, no, why?
Y8
minus
Y3.
Good.
3Y.
What about this one?
X1.
X.
X
plus
XY.
X plus 1.
I don't need to put the 1. It's invisible. Okay. Using all the properties, solve each equation. Now I have to do what?
Solve it.
Distribute first. 3
And
times 4 is
12X.
3Y.
plus 3y. Can I simplify this?
Yes.
By doing what?
Adding the 2X and the 12X. So
What's 2x plus 12x?
14X plus 3Y.
Good. Okay, what about this one?
5A plus 2B.
So I can combine like terms. It'll give me 5a plus 2b. Okay, what about this one?
4
plus
6, 18.
Okay.
And then
And
12b
12b.
plus
Can I
2a.
combine like terms?
Oh,
No.
No, I do not have like terms. That's as simplified it's going to get. This is actually supposed to say expression, not equation. All right, what about this one? Do I have like terms?
Yes. 4y and y.
4y tesseract plus
4
y.
4 power.
Okay. So 4 plus 1 is, stop talking back here.
5y.
5y to the power of 4 plus
3y.
3y
Does
squared.
that have like sort of like cubed or squared?
Tesseract.
Like
No,
the
that's
fourth
tesseract.
tesseract.
Yeah, there's a list on the board. If you're interested. You don't have to know.
Well, because like they like 2D and then 4D and then they or 2D and 3D and then they make 4D. Like
Okay, so let's take a look at these problems. I want you guys to do these in your notebooks. Okay? 7x squared minus 2x plus 6 is subtracted from 9x squared minus 8x plus 6. How do I rewrite this?
Combine them, right? What's she like?
What's being subtracted?
The big number. The big number.
Yes. Now, the second equation needs to be written in parentheses. Because you are subtracting. It's going to change the outcome of your problem. Please do this in your notes, everybody. You need to be working this problem out. I need to distribute negative. 9x squared minus 8x plus 6 minus 7x squared plus 2x minus 6. Okay? I lost my recorder. Okay, can I combine like terms?
Yes.
Which ones?
9x
to the 7th
squared.
power, 7x to the 6th
So what's 9 minus 7?
2.
So I've got 2x squared. Can cross that off. What's next?
Negative 8x plus 2x.
So negative 8 plus 2 is?
Negative 6.
Okay, cross that off. Now what's next?
6 plus negative 6.
So 6 minus 6 just gives you.
0.
So what's your answer choice? Okay, what about this one? Okay, sum means that we're going to add these. So I don't have to write my second equation into parentheses because it is positive. Okay. Plus 2x squared minus 3x plus 1. What are my like terms?
3x squared plus
And
Okay. Now what's next?
negative 3x
So it's 2 minus 3.
negative x.
Okay. What's next?
Negative 4
negative
plus
4 and 1.
What's negative 4 plus 1?
Negative 3.
Okay, so what's your answer? Good. Okay. You guys ready? No. What is the product? Product means we're multiplying. That means I have to distribute now. 3x times 2x is what? 6. But then what do I do? Since I have exponents that I'm multiplying. No, we add if we're multiplying.
To the 5th
To the power of 5.
Contract.
What's 3x times negative 12x?
36x.
Negative 36x to the power of
3.
3. What's 3x times 7?
24.
Plus 21x. All right, so what's our answer choice?
G.
G. Okay?
So, like, the number counts like multiplied by all three.
You multiply by all 4. Okay. You guys ready? Okay, let's take a look at scatter plots. Drag each scatter plot to the correct data correlation description. Okay, when I'm looking at scatter plots, I'm looking at whether or not it's a positive association of data, a negative association of data, or no correlation whatsoever. So what does this have?
No correlation.
No correlation. What does this one have?
No correlation.
Oh, whoa, whoa.
What does this one have?
Positive.
What about
No
this one?
correlation.
No correlation.
This one?
Negative. Negative.
Negative.
No
Positive.
correlation.
Negative.
No.
correlation.
Good.
Good job.
Positive.
Okay.
Oh yeah, that's what it was.
Our line of best fit. A line of best fit is a straight line drawn through as many points as possible with approximately the same number of points above the line as there are below the line. Okay. So I have a positive correlation and then I have a negative correlation. Okay. So this is my positive. This is my negative. So let's take a look at this one. How do I want to draw my line of best fit? One way to be able to do this is to draw a line on the outside, okay? And then you want to draw a line right down the middle. Try to get as many points on the line as possible, okay? So I have at least 2 points, 1, 2, but I have the same above as below, okay? Does that make sense? So if you guys are asked to write an equation, you make sure that when you draw your line of best fit that it's passing through as many points as possible, but we have an equal number above and below, okay? So here's what I'm going to do. I want you guys to get a calculator, okay? I want you to plot all these points. And I'm going to bring up my calculator. Hold on. Pause that for a second. I'll tell you about that in a second. Home screen. Click New Document. No, we do not want to save the document. Hit number 4. List and spreadsheets. Okay. Now, in the A box, you want to type in X. In B, you want to type Y. Okay. Now, for your list of data for the X values, we have 1, 2, 3, 4. Then it jumps to 6, 8, 9, 10, and 12. Okay, you guys ready?
Wait, so 1 is 1?
Yeah, don't worry about this over here. Just worry about our X values. Don't worry about the numbers on the left. Worry about the X values.
3.6, 8, 9, 10, and 12. That's it.
Okay. All right, you guys ready for Y?
No, 9, 10, 11.
Okay, I'm going to enter in the Y values. With 1, I have 10. With my X value 2, I have 4, 8, 12, 12, 16. You guys ready? $22, $20, $24. Okay. Now I was hoping when we did our workshop that you guys kind of remember a little bit since you guys actually had to do it. So once I have all of my information in my list for my spreadsheet, I'm going to hit Control and then the letter I. Now this is going to pop up. You're going to want to hit Add Data and Statistics. You guys remember that part?
Yeah.
So number 5. There's all your points. Now the points aren't as they should be, so we need to hit add our variable X. Okay. Remember that?
Yeah.
Then we're going to add our variable Y. What? Somebody help her out.
Oh, that part is 12.
Okay, so the next thing we need to do is we need to draw a line. We need to draw a line of best fit. So what I'm going to do is I'm going to go to menu, okay? And I want to analyze. I want to add a movable line. Bam. Now, you're going to, when you hover over it with your mouse, it's going to look like this. You need to press and hold that little part of your touchpad to grab it, okay? So you're going to have a hand that grabs it. You're going to move your line so that you have a line of best fit. When you move your line to your line of best fit, an equation is going to pop up. There's your equation. It's written for you already, okay? So instead of you actually having to go through and using all of those formulas to write an equation for the line, all you have to do is be able to remember how to do the scatter plots on your calculator, draw your line, and it'll come up for you, okay? Now, I'm going to go through, I'm going to enter, excuse me, I'm going to enter my calculator in press to test mode, okay? And I'm going to do this in press to test mode, see if it actually works. That way you guys will be able to do it on the test, if it's asking you what the equation is for that line of best fit, okay? You're going to mouse over and then press and hold the middle button.
My
No,
line
press
is not
and
moving. Where
You have to move it. You have to move it.
Okay? Does everybody understand how we got that line on there?
No. I was hoping
Okay. So here, the scatter plot below represents the number of guppies Carrie bought each month for 6 months.
What'd she do? Blush her up?
What is the correlation between the number of guppies and the number of months? What type of correlation is this? Positive.
Totally get it.
Okay,
Oh,
next.
yeah.
And it just gets bigger.
A tanning club advertises a membership plan in which each member pays a flat fee of $30 to join and $7 per visit to use the spa. The scatter plot below shows the cost for a number of visits by a member. Based on the data in the scatter plot, how much will a member pay on his or her 30th visit? So here's what you need to do. You need to be able to write that equation, okay, and plug 30 in for X.
Like, they have to pay, like, for the amount of times they go.
So here's what we're going to do. You guys need to know your slope formula, y2 minus y1 over x2 minus x1. Your point slope formula, y minus y1 equals m times x minus x1. I want everybody to work on this right now. I'm going to go around, and this is the last problem for today.
Got it.